Welcome back. This is an Aleks training video on finding mass percent from chemical formulae. Mass percent just means what percent of the molecule is the carbon responsible for, or what percent of the molecule is the lead in this case responsible for. So every one of these elements weigh a different amount. It has a different atomic mass. And you've got some where you've got more than one atom in a molecule. So if you have more than one atom, you would have more percentage of that molecule that one atom is responsible for, or whatever. So in order to find out a percentage, I need to know what the total amount would be, and then I need to know what the amount of that particular element would be, and then I divide it out. If I want a percentage of your grade, I take the number you got right out of the number total possible, and then the number right over possible as a percentage is your grade. So I need to know what the molecule weighs, then I need to know what the atom in question weighs, and then take the atom's weight, divide it by the molecule's weight, multiply it by 100, and that's going to be your percentage. So maybe seeing it might help you a little bit better. The question it asks is calculate the mass percent of oxygen. Okay, so I'm only interested in oxygen in the whole molecule. So I need to know what the whole molecule weighs. So that's its molar mass. So we find out what its molar mass is. Then we find out what the molar mass of just the oxygen would be. And then take the oxygen's mass, divide it by the total mass. You'll get a decimal, and then multiply it by 100%. So if you got a decimal of 0.72, 100% would be 72%. Okay? So let's first find out what the whole molecule weighs. I need to go to the periodic table for this. Always the periodic table. You have to know what these things are. You have to look them up. So I'm going to start with lead. I've got one atom of lead in this molecule. So let's do it this way. Lead, I've got 1 times, and its weight is 207.2. So since there's only one, it's 207.2. The next atom that I have is nitrogen. I've got 2 nitrogens because there's a subscript out here. So I have 2. I look up the weight or the atomic mass on the periodic table, and for nitrogen I have 14.0067. So I'm going to have to double that. 14.0067 times 2 gives me 28.0134. Okay. The last one is my oxygen. My oxygen, I have 2 times 3. I have 6 atoms here. When I look it up, it's going to be 15.9994. So I have 15.9994 times 6. And I have 95.9964. I'm going to add those together. Plus 28.0134 equals plus 207.2 equals. Okay. I'm going to have 331.28098 as my total grams. That's the total grams of what this molecule weighs. Now that goes on the bottom. That would be out of a possible 10 points or whatever. 3 points right out of 10 points possible. Here's the amount of weight the whole molecule weighs. How much does just the oxygen weigh? Okay. Well, I've already done the math. Oxygen, there are 6 oxygens in the molecule. Here's the atomic mass of oxygen. So here is the weight of just the oxygen. So I've already done it, so I'm not going to do it again. It's 95.9964. And now this means divide. So it's 95 out of 331. 95.9964, and I get that as a decimal, 0.2898, etc. and it asks me to round it to the nearest percentage. So when I multiply by 100%, it's going to be 28.98% rounded to the nearest percent. So the nearest percent would be 29%. Okay, 29% oxygen in lead nitrate. 28% oxygen. Okay, or 29% oxygen. Okay. Not terribly hard, but you may have to do this a couple times before it makes great sense to you. Okay, thanks.